Welcome to the NHERI SimCenter's Live Expert Tips, where we cover diverse aspects of simulation and modeling in natural hazards engineering. This session includes a technical example that demonstrates a feature of SimCenter tools relevant to natural hazards and their effects on the built environment. In today's session, we introduce you to regional assessment analysis with user-provided fragility functions within the context of a tsunami scenario for Seaside, Oregon. Through this example, you will learn how to implement your own custom fragility functions in a regional analysis. Our expert today is Dr. Stevan Gavrilovic. He is a postdoctoral researcher at UC Berkeley, where he is the lead developer of the Regional Resilience Determination Tool. His research interests include software development, nonlinear finite element analysis, and structural damage modeling. Stevan, thank you for being here.
Thank you, Matt. And thanks to everyone in attendance. So my talk today will focus on how users can employ their own fragility functions to conduct a regional analysis in R2D. Just zoom away here. So providing an outline for today's presentation, the first thing I will go over is how you can create, name, and format fragility functions so that they can be incorporated into the SimCenter workflow. And the second thing I'm going to focus on is how to provide an overview of how to write a script to map these fragility functions that you may have created or sitting somewhere to different building types. In this case, we're going to focus on buildings, but they could be different types of assets. I note that in reference to this mapping script, it will be helpful to know a little bit about the Python programming language, but it's not necessary. I'll try to explain everything as best as I can. So first thing, a little bit about the SimCenter. What you see here is a SimCenter framework. So it's a collection of software components to simulate risks to the built environment subjected to different types of natural hazards, earthquakes, tsunamis. And each app you see here corresponds to a particular type of natural hazard. And R2D, highlighted at the top, brings them together in a regional workflow. So the regional workflow follows a typical PBE methodologies of performance-based engineering, that is from hazard definition to density to asset modeling and response through these various apps. And finally, to the PBE app, which kind of orchestrates everything and uses Pelican as a damage and loss methodology. So now we see where R2D kind of fits into the big picture. I'll move on. So some resources for today, you can download the R2D tool at the tool webpage, shown at this link here. Some of the examples I'm going to go through, you can download them through the R2D graphical user interface or through GitHub. You can, of course, look at the R2D documentation to get a little more in-depth details of what I'm going to talk about today. And if you're brave, you could build R2D using the source code that can be found at this GitHub page. And when you want to run regional analyses with thousands of assets, you can do that at the design safe high-performance computer. For that, you'll need a design safe account. That's no cost. You can get that here. And you'll need those credentials in R2D to submit remote jobs. And there's also Pelican. If you want more details on the damage and loss methodology, which I'll talk a lot about today, you can find that in the Pelican code and documentation, which is sitting here. But first things first, you have a set of fragility functions and you want to use them in R2D or the SimCenter workflow. So here it provides some key points on what's important. So the fragility functions follow a JSON file format. You see a big long one here. I'll go through each one of these kind of sections one by one. But the key points are it follows a JSON file format. There's one fragility function group per file. And I'll get into what that means, but there could be multiple fragility curves in one group. All of these fragility function groups, these JSON files, need to be in the same folder. And all file names need to be unique. And that's going to be important later. You can look in the folder called Custom Fragilities in example 9 for these template or example fragility function files, where you can start from and kind of what I did. So this is pretty straightforward. The first thing is that you include general information such as a name. You want to be descriptive. You can have an ID, and you can also have these other attributes that can help you recognize the fragility function and what it can be used for. So it's kind of up to the user what to put here. The important one is going to specify the engineering demand parameters. So next down, we're going to specify the EDP, the type, and the unit. In this case, you see I have a mile per hour and peak gust wind speed. But in your case, that might be different. So this type of EDP needs to match what's sitting in the Pelican script base.py. So when I first created this, I had to go here, see the different EDP types, and then match that with the EDP type in your JSON file. Again, this code can be found on GitHub, or it's also bundled with R2D in the backend applications perform DL Pelican folder. So if you're thinking, this is a type, what type of EDPs can I use? How does that tag look? You go here and you can figure that out. And also similarly for the unit of the EDP, it needs to match the unit type keys that are sitting in the SimCenter common .py script. So here it's simple, miles per hour, I go to speed, I find it, and you could use these different tags to assemble the EDP part of your fragility group. And this is an important part. So now we get to the damage state groups, or the DS groups. So a damage state group is an array containing one or more of these damage state curves. You kind of see here. So each item in the array defines one of these curves. So here I show these first two curves. There could be more. And I'm going to talk a little bit about what these damage states are. So the idea is you have this array called the DS group, and then you populate that with your damage state curves. So for each fragility curve, we need to specify the median and the beta parameters, the curve type and the group type, which I'll go into more detail next, and also the damage states. So the median and the beta parameters are the two parameters that define the shape of your fragility function. That's pretty straightforward. And then we got the curve type and the group type. So the damage state curve type pretty much describes whether it's a log normal or normal type of fragility curve. And your group type describes the relationship between the fragility curves in a group. So whether they're sequential or single, simultaneous, or mutually exclusive, sorry. A sequential means a component must enter one damage state before it enters the next. Simultaneous means that all damage states can occur at the same time. And mutually exclusive just means a damage component can only be in one damage state. But if you go to this file _io.py, you'll see the different curve types available, and then the different group types to help you fill this out. And of course, more information about all of this, what I'm talking about, is available in the Pelican documentation. So I'm trying to describe here how you can create one of these fragility group JSON files kind of from scratch, and where you can go in the code to link the two. Now into the important ones, so your damage states. So each one of these damage state groups has multiple damage states. And a damage state, of course, characterizes one particular type of damage within a damage state group. So an example could be a minor damage state, a moderate damage state, severe, that sort of thing. And within these damage states, we're going to define the weight. And then the important part is the consequences. So we could have multiple consequences for a particular damage state. Different consequence types are injuries, reconstruction cost, reconstruction time, red tags. And finally, description down here, which is any text to help provide some information about type of damage states, like I said, minor, moderate, collapse, so on. So you just pretty much populate this array with your different damage state groups, and then your different damage states. So I'll go back here quickly. Now I know this is a quick overview, but hopefully you have an idea of how you can create one of these custom fragility group JSON files. And I'm also going to show you a real life one in a second when I provide the R2D demo. But yeah, this is kind of just a way for you to link what's in one of these files and what's sitting in the backend code. And the best approach would be to review the files in example 9 and go to the different parts of the source code that I mentioned to see where that link happens. Now I'll talk a little bit about the fragility mapping, or what we call Autopopulate script. So key points are it's written in Python. It contains a single function to map an asset to fragility group, so those JSON files I talked about previously. It returns 2 objects, so a damage and loss object and a BEng object, and I'll talk about what these are. And template autopopulate scripts are provided in 3 R2D examples, so 7, 8, and 9. The one I'm focusing on today has these template autopopulate scripts for you to go through to get an idea of how they run and what they work. But in a basic nutshell, this autopopulate script has one function. It's called autopopulate. Now this function signature needs to match this format shown here, so don't change this. And BEng is the only input. And what this BEng is, it's a dictionary of asset attributes. So the purpose of this script is it gets run for each asset. And at the end, it should return the proper or appropriate fragility function for that asset. So that's what we're trying to accomplish. And this BEng is important because it contains attributes. So a little bit about the BEng first. It's something that you don't have to create. It gets created automatically by the SimCenter workflow. One BEng file, I should say, is created per asset. And again, that's in JSON format. And this is an example of how that looks. And importantly, this BEng contains the asset attributes, which are used in the script to determine what type of fragility group I want to use for that asset. In this case, different type of attributes are number of stories, year built, structure type. And all these attributes are from your building inventory. So I'll show you how you can import building inventory in different ways. For example, in a CSV file or as a GIS format. And all those attributes will show up here in this BEng. So as I mentioned previously, these asset attributes are important. In this case, I use 1. So here's that dictionary. It's as simple as saying get. In this case, I use number of stories. And I'm going to use the number of stories to map this particular building to these fragility functions. So in this simple example, I have 3 fragility functions. So building 1 story, building 2 stories, and building 3 and above stories. And down here is the logic that I use. Down here is the logic that I use to map this particular attribute, so number of stories, to these 3 fragility groups. Now, of course, this can get as complicated as you want. You could use the building material construction type, the age built, and so on and so on. But this is a simple example. So what I do here is, depending on the number of stories, I create this Fragility Function Tag, which is essentially the name of that file in my custom fragilities folder. So remember previously I said all these fragility group JSON files need to go in one folder. And now in this autopopulate script, this has to be a one-to-one mapping. So this string right here, building 1 story, needs to match the file name of that fragility function sitting in my custom fragilities folder. And note, do not include the JSON suffix here. So just the name that will get added by the workflow. And the last step in this autopopulate script is we need to assemble the damage and loss object. So this is one of the things that the script returns, the DL app in this case. And this is an example of how that looks. So here's where that fragility function tag comes into the picture, right here under this components item. Don't worry too much about this here. This is for more sophisticated analyses and An explanation of what these different items are can be found in the Pelican documentation. But for now, just pass the fragility function tag as this key here in this components item. Another thing we have to define in this damage and loss object that we're returning is the type of method. In this case, I'm using a hazardous type TN just for tsunami. But there's also earthquake, hurricane, flood, and you'll want to put your damage and loss method right here. And then you want to turn on what type of decision variable that we're interested in. So in this case, I have reconstruction cost as one of my consequences in my fragility function. So that's what I want to use as a decision variable. So I also want to point this out. So here's the damage and loss object. Here's our fragility function. So you want to have this mapping between the different consequences here and what you're requesting here in the DL object. So I'll show you a real file of how this looks in a second here. And this Seaside, Oregon example. So this is example 9 at the SimCenter, or the Seaside testbed, which is from the Interdependent Network Community Resilience Modeling Environment, or INCOR, which is part of the NIST Center of Excellence. So the parts of this example that I took from INCOR are the GIS building inventory, the tsunami hazard raster, so you see it kind of shaded in blue here, and then the tsunami building fragility function. So INCOR has this web tools platform where you could register at no cost, and you could download different types of asset inventories, different hazards, and also look at different fragility functions. So I took that from the INCOR and converted it into our example 9 here in R2D. Before I open R2D, I want to focus on the new addition, which is to the Pelican damage and loss module. And that's this user provided fragilities. So you'll notice there's 2 things here that you got to provide. One is that Autopopulate script that I talked about, and another is a path to that folder containing all those user-defined fragility functions. So once you create that Autopopulate script, you have your fragility functions in the SimCenter format. You put them in a folder, point that folder here, and you should be good to go. And I'm going to open up R2D. A second here. Okay, so here's R2D, and I'm going to load example 9 to help go through it. So as I mentioned previously, you could load the examples through R2D. You could click here on Manage Examples, select the ones you want, click Update, and they'll be downloaded from the server and installed on your computer. In this case, I want to load example 9, so I'm going to go up here, click on example 9 tsunami, and here we go. So I'm just going to move this raster, rearrange things a bit so I could look at the buildings a little better. Maybe I'm going to color the buildings something else because it looks pretty close. Okay, now you can kind of see how things look. Each one of these parcels is a feature here in QGIS, but I'll get to that in a second. So now I'm going to go through these different tabs in R2D. And again, it follows a performance-based engineering workflow where you got to define the hazard, define the asset, define the modeling and analysis modules, and finally damage and loss methodology. So starting at GI, which is general information, this is pretty straightforward. Again, it's just you give it a name, you assign the units, and the asset layer. In this case, we're analyzing buildings. In hazard, I have that raster defined hazard, which is a raster, a TIFF file that I just downloaded from INCOR as is. And you want to specify the event type and then the coordinate reference system of your raster. And finally, the units of your input file. So a raster could have more than one band. In this case, they only have the peak inundation height or the maximum height of the water in meters. Here's where I define my building inventory. So this is the Seaside buildings, again, taken from INCOR. I had to make a few small changes, like adding an ID here at the start, and these latitude or longitude and latitude fields as well. But other than that, all these other columns you see are directly from the shapefile that I got from the INCOR group. And you'll notice here the number of stories is one of these columns. You have year built, structure type, and a lot of other information that we don't use in this case, but could be used to assign your own fragility function. So each row here is a building, and all these attributes will appear in that BIM file for that particular building. And I will show an example of how that looks. Next, we have the hazard to asset mapping. And this just maps the building to the hazard. In this case, it's site specified, which means at each parcel here at the centroid, I'm going to sample the raster and get the value for that particular. For example, if I click and identify raster hazard, the water height here is 0.4 meters. So not too much, so it's 0 there. And it gets larger and larger the more closer I get to the shoreline. And also depend on the topography of the land as well. But the idea is I'm mapping at each centroid, I get the value of this raster and send it to the back end. Here I have no building model, so I'm going straight from intensity measure to EDP. So I'm taking the height in meters of the tsunami inundation depth and using that as my EDP in the damage and loss. And here I'm using Pelican, and my damage and loss method is user-provided fragilities. There's other options with pre-bundled fragility functions, such as HAZUS, MHHU, so hurricane or earthquake. But here we're focusing on user-provided fragilities. And as I mentioned before, here's a location to your Autopopulate script. So you get to tell R2D where your script is located, and also the folder containing the user-defined fragility function. I'm going to click run, but at the same time, now I'm going to show you how these different scripts look. So here's my example 9 tsunami folder. This is the input file. Essentially, this is what gets created by the R2D front end. I'm not going to spend a lot of time here, but all those different apps I showed you populate this input file. Now see here, I have that folder called custom fragilities. Here are the building, different fragility groups for the different types of buildings, 1, 2, and 3 story. I'm just going to open one up. And now you can see an example of what I was talking about. So I have the general information up here. I define my EDP, which is a maximum tsunami depth, the unit. Here's where I have my damage state groups. Each one of these is a damage state. So I have right here, major, complete, and collapse. And then I find the median, the beta, the curve type, single, and in this case, the consequence. I only have one consequence here, which is reconstruction cost, and this is more or less a loss ratio. So of course, you could come here to this custom fragilities folder and start with one of these JSON files as a template for your project. Here's an example of how that GIS building inventory looks. It just, in this case, I converted it into geo package. I downloaded it from INCOR as a shape file, but it's up to you. You can have a CSV file. You can have a different GIS file formats to use here. The important thing is you got to have the first column has to have an ID, which is just a sequential number from 1 or 0 onwards. And you got to have a lat and a long column. Here's my intensity measures. So in this case, I'm using the 500-year return period tsunami raster. This was from probabilistic hazard analysis. So this is again from the INCOR folks, but you can create your own grids or rasters or whatever to use. And I also included the original INCOR fragility functions as a starting point to see. So this is how they send their fragility function. So this is the 1-story building. It's also in JSON format. And just to give you an idea, so they have curve parameters, limit state tsunami. So very similar to what we have, but slightly different. So you can download this, take the different parameters out of here and put it into the SimCenter format. Or if you have your own, just follow the SimCenter format. And at the bottom here, I included another sample. So if I go here, here's another more, let's say, complex example using the SimCenter format and 4 different damage states. And here's the auto-population script. So this is the fun one. Make it bigger. So as I mentioned before, there's only one function, autopopulate. It takes a BEng. And as I mentioned, it also returns 2 things. So the BEng and the damage and loss objects. Up here, I just set the BEng that I'm returning as the BEng that came in. So it just passes through. You do have the option to add your own data. So it's called extended BEng data to this BEng. So really sky's the limit. You can create, combine different attributes, create your own attributes in the script, and then assign them to the BEng to go forward into the analysis. So it's really simple here. I just call BEng get number of stories, and you'll notice that this number of stories matches this column heading over here. It's going to be somewhere here, number of stories, yep. And here's the logic where I figure out what my fragility function tag is. So I have a bunch of if and else statements. I get my fragility function tag. And if I go back here, again, you'll notice that these file names are 1-to-1. So they have to match. And here's that DL app that also gets returned at the end of the day. And this is where that fragility function tag sits in the big picture. So it looks like this analysis is complete. So here I only analyze the strip of buildings. If I turn on the rest of the buildings, as you can see, there's a lot more, but I only selected a strip. You can do all or one or however many you want. But you'll notice here that, go back here, that the closer you are to the water makes sense, the more damage your building will sustain. So if I identify this feature, and I go down here and I look at the loss ratio, it's about 86%. Click this one, 56. This one, 0, right? So at this point, there's no more water. The tsunami only made it this far. And that's that. Now I'm going to show you how the results look. So if I go to R2D, this is my local work dir, which you could set in the preferences. And it's by default in this temp.simcenter folder. And if I go to results, I'll maybe select one of these buildings over here. And here's that BEng.json file that gets created by the SimCenter. So you can always go here and see which keys or what information, what attributes are available for you in that autopopulate script. So everything you see here shows up in that, you can get access to in that autopopulate script. And then I don't know if this building was damaged. Let's see. This is also where you see the results for the individual buildings and also the results for all the buildings. So yes, in this case, this building was a little bit damaged. So I get the repair cost and some other statistical measures here. Okay, that's that for my demo. And go back to the presentation. So don't miss these other upcoming live expert tips coming up in April here with the Sangri, Adam, Quanchi, and Akash. So I recommend you check these out as well. The registration link is down here at the bottom of the screen. And finally, if anyone has any questions, you can go to the SimCenter forum. If you have any trouble setting up those fragility function JSON files or autopopulate script, and go down here, put in a forum post, and we'll help you out. And yeah, that's it. Any questions?
Thanks, Steven. It was very informative. I liked that there was one fun, exciting script in there. You pointed out that that one was fun. So great. At this point, we don't have any questions. I guess to the attendees here, if you have a question, maybe drop that in the chat. Otherwise, we can adjourn early. So yeah, we can give people a few minutes to ask questions. Maybe Steven, you've pulled fragilities and data sets, and I guess the hazard as well from INCORE.
Correct, yeah.
Would it be easy to pull in some of their other test beds as seamlessly, or what would need to be done?
It would, yeah. So at this point, it would be as easy as pulling their fragility functions, converting it into our format, and then using their building inventory hazards. It's all set up, should be good to go.
Okay, well, barring any addition, there is one question just in time. Is it possible to compare results obtained that might support the validation of, I'm not sure if it's a validation of the SimCenter's tool or of the scenario? Maybe the person who asked the question could elaborate.
Yeah, so let me see, would it be? Oh, so validation between SimCenter and INCORE tools. So yes, it would be interesting, I agree. Haven't got that far yet. I mean, I'm running the two in parallel, and yeah, we'll get there at one point. But this is kind of hot off the press. So the idea is we will validate them and compare.
Okay, well, second question. Have you looked into combining damage for different hazards?
So by combining, perhaps you mean like an earthquake before the tsunami? We have looked at it, but it's not yet implemented. So yeah.
Mm-hmm. So not yet is the answer. Great.
Yeah, not yet possible. But we are thinking about it for sure.
Great. Okay, well, without any other questions, Steven, thank you very much for the presentation. Thank you for being here to the attendees. And this concludes today's live expert tips with the NHERI SimCenter. We hope you've been inspired to pick up this example, adapt it to what you might be working on, and look forward to seeing some of those results from your research.